My name is M. NARASIMHARAO, lecturer in physics. Today, I am explaining the time period of the particle of mass m when connected by the three springs as shown in this diagram. Now please listen. P, Q, R are the three springs connected to the particle of mass m such that angle between the springs Q and R is 90 degrees. These three springs are identical. Each spring is having the force constant K. Suppose if the particle of mass m is vibrating along PO vertical direction, what is the time period of oscillation they are asking? Initially, this particle is connected to these three springs. Initially, the particle is in the rest position. Initially, the particle is in the equilibrium position. Resultant force acting on this particle of mass m, which is situated at O, is 0. This position you are calling as equilibrium position. Now please listen. After some time, this particle of mass m is pressed downward through a distance of y. After some time, this particle of mass m is pressed down along OP direction through a distance of 2 cm, to a distance of 3 cm, to a distance of 5 cm, to a distance of 1 cm. Now, after some time, this particle is pressed down, pushed down along OP direction through a distance of y. Now, this is the distance of y. From O to O dash, the distance is y. This is the new position of this particle of mass m, and we are pushing this mass. We are pushing this particle in downward direction along OP direction through a distance of y and left free. Immediately, the first is when we press it down along OP direction, this spring P is compressed by a distance of 2 cm, by a distance of 3 cm, by a distance of 1 cm, by a distance of y in downward direction along O dash. At the time this spring P is compressed by a distance of y. At the same time, when this particle of mass is moving from O to O dash, it is compressed by a distance of y. At the same time, this spring Q is elongated and the spring R is elongated. Now please listen. From this particle, you draw one draw from this mean position, you draw one perpendicular on this. You draw one perpendicular on this. Now here the angle is 90 degrees. At the same time, you draw one perpendicular on this spring. You draw one perpendicular on this spring. Here angle is 90 degrees. Now you observe the diagram carefully. This length of the spring and this length of the spring equal. This length of the spring and this length of the spring is equal. This is the additional length of the spring. This is the elongation in the spring Q. This is the stretched. This is the elongation in the spring Q. Now, the spring, when this particle of mass is pushed down and along OP direction, this is the displacement. This is the compression in this spring. At the same time, this spring is elongated by a distance of of y dash. This spring also elongated by a distance of y dash. Now this spring is elongated by a distance of y dash. This spring is elongated by a distance of y dash. Now I will find the elongation in the spring Q, elongation in the spring R. When this particle of mass is pushed along OP direction, the spring is compressed by a distance of y. At the same time, this spring is elongated by a distance of y dash. This spring is elongated by a distance of y dash. The reason is these three springs are identical. It is elongated by a distance of 10 centimeter. Suppose if it is elongated by a distance of 3 centimeter, means it is also elongated by a distance of 3 centimeter. Here the elongation I am taking as y dash. Here elongation I am taking as y dash. You see here? You see carefully? Now it is one perpendicular drawn onto the spring. Now this is the elongation. It is the right angled triangle. It is the right angled triangle. O dash distance, nothing but compression in the spring P. This compression is y. Elongation in the spring Q is y dash. Here this angle is 90 degree. I am finding the elongation in the spring Q. I am finding y dash. Here I am writing very clearly. Elongation in the spring. Elongation in the spring Q. Elongation in the spring Q. We need this elongation. In this triangle, it is the right angle triangle. We need y dash. It is the adjacent side. It is the hypotenuse. I am taking the cos theta. I am taking cos 45. Cos 45 degrees. Cos theta means adjacent side by hypotenuse. Cos 45 is equal to 45 degrees के adjacent side. 45 degrees के adjacent side is nothing but y dash. Y dash. Hypotenuse. It is the hypotenuse. Hypotenuse is nothing but y. Now, cos 45 means 1 by root 2. That is equal to y dash by y. Y dash by y. Y comes to numerator. Y comes to numerator. Y by root 2 is equal to y dash. Y dash represents the elongation in the spring Q. Same elongation is present in the R. Spring R. Now please listen. When this particle of mass M is pressed down along OP direction, when this particle is coming to here, immediately this spring is compressed. At the same time, inside the spring, restoring forces are developed in this spring. Restoring forces are developed in the spring. Restoring forces are developed in the spring. Restoring force means the force which brings the body to the original position. This particle, when this particle is pushed down, the particle is came to new position here. This when the particle is coming down by over dash distance, nothing but y, the spring is compressed. At the same time, this spring is elongated. This spring also elongated. If you left free, due to the restoring forces, this particle again goes to O, and again due to the restoring forces, immediately this particle moves up, again moves up and down. This particle is oscillating up and down, or this particle is oscillating to and fro about the mean position. These oscillations we are calling as the simple harmonic oscillations. We have to find the time period of this simple harmonic oscillations. And one more thing, when we press it down, immediately restoring force are developed in this spring and this spring and this spring. Those are this now when you press it down, compression is down by a distance of y. Immediately restoring force is acting in upward direction. Restoring force in the spring P is in this direction. Restoring force that is a restoring force due to the P. spring P. Restoring force in this spring is in this direction. FQ, restoring force, the force which is bringing this body to original position. Restoring force in this spring is in this direction, FR. And one more thing, please listen here. Please listen here. Restoring force in the spring Q is in this direction. It is making 45 degrees with the vertical. This FQ I am dividing into two components. One is FQ cos theta, FQ cos 45 and FQ sin 45. FQ sin 45. Right. Next. Now restoring force in this spring is acting along OR direction. This restoring force is making 45 degrees with the vertical. Now this FR can be resolved into FR cos 45 degrees and FR sin 45 degrees. FR sin 45 degrees. FQ and FR both are equal in magnitude. Sin 45 equal in magnitude and opposite in direction. These two will be cancelled. Now please listen. Now I need the total restoring force along the PO direction, along the vertical direction. Now restoring force due to the spring P is acting upward FP. Restoring force due to this spring is acting in upward FQ cos 45. Restoring force due to the spring along vertical direction is FR cos 45. Now, total restoring force on the particle of mass m by these springs is in vertical direction. Total restoring force. Total restoring force. Total restoring force along vertical direction, along PO direction. Total restoring force means what? Restoring force applied by this spring, restoring force of this spring along vertical direction, restoring force of this spring in vertical direction. Total restoring force is equals to restoring force of the spring P in upward direction FP plus restoring force of this spring along vertical direction FQ cos 45. These three restoring forces are upward direction or in the same direction. For that reason we are adding FQ cos 45. FQ cos 45 degrees plus restoring force of this spring or along vertical direction FR cos 45. Now please listen here. FP, restoring force of the spring P in this direction. Compression is in downward direction and restoring force is in upward direction. Now, please listen. Restoring force applied by this spring is restoring force of the spring formula Kx, otherwise Ky. Here compression is Y. For that reason, restoring force of the spring P is Ky plus restoring force of the Q. Ky dash. Why I am writing Y dash means elongation in the spring Q is Y dash. For that reason I am writing Ky dash cos 45 plus restoring force in the spring R along vertical direction. Restoring force formula Ky dash. The reason is elongation is Y dash. Cos 45 I am writing cos 45 in this direction. Y dash. Y dash means Y by root 2. Y dash means Y by root 2. Y dash means Y by root 2. Cos 45 degrees. Cos 45 degrees means 1 by root 2. K I am writing K. Y dash y dash means y by root 2, y dash means y by root 2, cos 45 1 by root 2, that is equal to ky, k into y, ky into 1 ky, root 2 into root 2, 2, root x into x, root x into root x is equal to x, root 2 into root 2, 2, ky into 1 ky by root 2 into root 2, 2, that is equal to ky, half ky, full ky by 2, ky by 2, ky by 2 plus ky by 2, ky by 2 plus ky by 2, 2 ky by 2, 2 gets cancelled, ky plus ky, 2 ky. Total restoring force along PO direction is equals to total restoring force. Total restoring force is equals to what we got? 2 ky. 2 ky. 2 ky. Restoring force formula. Total restoring force of the system. Total restoring force of the system, that is equal to k dash y. That is equal to 2k into y. Y gets cancelled. K dash is equal to 2k. This is the effective spring constant of the system. Now this mass, the particle of mass is oscillating up and down in this direction, along vertical direction. We need a time period. Time period of the loaded spring. General formula. Time period of the spring. Time period of the loaded spring formula. Time period of the spring formula 2 into 2 pi. Time period of the spring formula 2 pi into under root of m by k dash. M by k dash. K dash is the effective spring constant. T is equal to 2 pi into under root of m by k dash. K dash means 2k. Now this is the time period of oscillation of this particle. Thank you.